Lesson 2, Arithmetic Series. An arithmetic series is the sum of the terms, so all of them added together, in an arithmetic sequence. So 5, 7, 9, 11, 13 would be an arithmetic sequence, but 5 plus 7 plus 9 plus 11 plus 13 is an arithmetic series. You can write any generic sum of an arithmetic sequence like this. So the sum up to the nth term, which would be a plus n minus 1d from the first lesson, is a plus d plus a plus 2d, and so on and so forth until a plus n minus 1d, where a would be the first term and d is a common difference. If we write this sum again, but in the reverse order, it would be a plus n minus 1d plus a plus n minus 2d, and so on and so forth, until a plus d plus a. If we call this 1 and this 2, and then we add 1 and 2 using standard column addition, if we add a plus n minus 1d to a, we get 2a plus n minus 1d. If we add a plus d to a plus, if we add a to a plus n minus 1d, we get the same thing. We get 2a plus n minus 1d plus 2a plus n minus 1d, and it keeps going until again we get 2a plus n minus 1d. And so this is happening n times. You're adding it n times for the n terms in the sequence. So 2Sn, which was Sn plus Sn, is equal to n times 2a plus n minus 1d. And so dividing by 2, we get Sn equals n over 2 times 2a plus n minus 1d. And that's the generic formula for the sum of an arithmetic sequence. Another version of the formula can be derived like this. If we this time include L as the last term, if the last term is known, then we can do a similar method by labeling this 1 and then making equation 2 Sn again, but in reverse, L plus L minus d plus L minus 2d, and so on and so forth, until a plus 2d plus a plus d plus a, until we get to the beginning again. Now if we add 1 plus 2, 2Sn this time is equal to, if we add a and l, we just get a plus l. If we add a plus d plus l minus d, the d's cancel, so we just get a plus l. And this happens all the way until the end. You get l plus a, which is a plus l. And so you get this n times, because there's n terms in the sequence. So 2Sn equals n times a plus l. So Sn equals n over 2 a plus l, which is the same thing as n over 2 times 2a plus n minus 1d. Sometimes this will be easier to use, and sometimes this is easier to use. Let's do an example. Let's find the sum of the first 50 terms of the arithmetic series, 32 plus 27 plus 22 plus 17 plus 12. Here we can see the first term, a, is 32, and the common difference is we're subtracting 5 every time, so it would be minus 5. We know that the standard formula is n over 2 times 2a plus n minus 1d. So we can say s of 50 is 50 over 2 times 2 times 32 plus 50 minus 1 times minus 5. And this will give you minus 4,525. One last example. Let's find the minimum terms needed for the series 4 plus 9 plus 14 plus 19 to exceed 2,000. We know a equals 4 and d equals 5. S of n equals n over 2 times 2a plus n minus 1d. If we plug in the values that we know, we get 2,000 equals n over 2 times 2 times 4 plus n minus 1 times 5. Doing some algebra, we get 4,000 equals n times 5n plus 3, which is 5n squared plus 3n. We get 5n squared plus 3n minus 4,000 equals 0. Then using the quadratic formula, we get n equals minus 3 plus or minus the square root of 9 plus 80,000 all over 10. So n is equal to 27.99 or minus 28.59. However, as we're doing the sum of a sequence, we can't have a negative, so it has to be a positive only. So if this is the minimum, n must be 28 terms are needed. And that's it.